Second half of chapter or section 10.2 is rules for rational exponents. Now, remember, rational exponents are exponents that are fractions. All of the rules that worked for real numbers that were exponents are going to be the same, except that now we have fractions in those exponents. So let's bring back the rules for exponents. Remember, a zero exponent, anything with a zero exponent is 1, and that's going to be true. Obviously, if it's 0, it's not a fraction, so we probably won't see very many of those. If you have a negative exponent, remember it flips the whole base down to the bottom of your fraction, or if it's on a whole fraction, it flips it. The product rule, if you have the same base raised to, and you're multiplying the same base raised to two different exponents, you're going to simply add the exponents. If you've got a fraction and you've got the same base divided by the same base, but you've got different exponents, you're going to subtract your exponents. Power to a power raised to a power, you're going to multiply those exponents. Product of power, so if you've got two numbers that you're multiplying and you're raising that to a power, you've got to remember to put the power on both parts of your product. And then quotient to a power, so if you're raising a fraction to a power, both parts of the fraction, the numerator and the denominator, get that exponent. All right, so all of that are rules that hopefully you already know. And so what we're going to do is we're simply going to do lots and lots, again, lots of examples. I don't really know how to teach this to you except just to give you lots of examples to see, oh, this is what you do in this case and this is what you do in this case. So here's the actual rules. So if you want to put those down in your notes so that you have them, you can have them on your note card for your test if you'd like. But here's how they work in real life, or in your real life math assignment. Here we go. So x is the same base, and we've got to the 1/5 power and the 3/5 power. So remember, in the other sections we've seen how we can change that to a root. You could change it to a root, but it's a lot easier to deal with this as an exponent. That's why I showed you how to change the root to an exponent that is a fraction. So now we've got, in this case, because we're multiplying these two, we're going to have x to the 1/5 power plus 3/5 power. So when we add that, it's just x to the 1/5 plus 3/5, it's x to the 4/5 power. And now in that case, your denominators were the same. It's going to make life easier. Some of them I get mean and I give denominators that are different, but you know how to get like denominators and add those. So then you can go on and put x to the 4th to the 5th root, but let's just leave those for now. Let's just leave them a fraction exponent. It'll make life easier. For right now, this is what I want you to learn how to do. So here you've got two numbers that you're multiplying, but you've got coefficients. And now if you'll remember, when you've got this, all of this is just multiplied together, so you can do it in whatever order you want. So it's easiest if you put this 2 times 4 together, and then the a to the 1/2 times a to the 1/3. So you've got 1/2 and 1/3, you've got the same base, so you're going to have 1/2 plus 1/3 powers. Did you see where I got that? I did 2 steps in one. So this is a to the 1/2 times a to the 1/3, and when you're multiplying those, you can just add the exponents. So 2 times 4 is 8, and now with this, you're going to have to change this. Let's change it to like denominators. So let's give it a 6. So this is 3/6 plus 2/6. So now this is 8 times a to the 3, 4, 5, 6th power. All right, 8a to the 5/6 power. So you multiply the coefficients, and then to multiply your bases with exponents, you simply add those exponents. But in this case, you got to get like denominators to do it. Okay, moving along. Now we've got a division problem. 5 to the 2/3 power divided by 5 to the 3/4. Now this looks like a fraction. It looks scary. Don't forget that fraction bar is just a division sign. So this is the same as 5 to the 2/3 divided by 5 to the 3/4. And if you'll remember, the quotient rule says if we're dividing, we simply subtract the exponents. So the base is the same. So 5 to the 2/3 minus 3/4. All right, so let's change those. We need like denominators. 3 and 4 are our denominators, so 12 is going to be our common denominator. And 3 times 4 is 12, so 2 times 4 is 8. 4 times 3 is 12, so 3 times 3 is 9. So 8/12 minus 9/12, so we've got 5 to the negative 1/12 power. And remember, we don't want negative exponents left in our answer. So remember now this becomes 1 over 5 to the 1/12. Because of this rule here, negative exponent flips that down to the denominator. Yeah, easy. You getting this. Okay. Once again, this is actually very similar to what we just did up here. So we're going to multiply our, oh, you know what? I forgot. I forgot the y in there. Y to the 4/5 power. Sorry. Okay, there we go. Typo. All right, so now we're going to work this the same way we did this. We just have to be careful with negatives now. It's exactly the same type of problem. So we've got -4 times negative, or not negative, just times a 5. And then we're going to multiply that by y to the negative 3/5 and y to the 4/5. Now, what we do there is because this is negative and this is positive, we can still just add them, all right? When you add with different signs, you're actually subtracting. Remember these rules? So y to the negative 3/5 plus 4/5. Easy sneezy. So now negative 4 times 5 is negative 20. Whoop, I'm going to run out of room here. I'm going to have to start squishing. Negative 20 times y. Negative 3/5 plus 4/5 leaves me with 1/5 left. So to the 1/5 power. Negative 20y to the 1/5. Easy. All right. This one shows raising a power to a power. You've done that before with whole numbers. Now it's just with a fraction. So this is going to be w to the 3/4 times 2, and you can just put that 2 over 1 to remind yourself. And remember, with multiplying fractions, you can reduce before you multiply. This 4 and this 2 will reduce down. So now you end up with w to the 3/2 power, and don't change those improper fractions to mixed numbers when they're exponents. Leave them improper fractions. So w to the 3/2 power. Done. Easy, easy, easy. Same thing here. Now this one represents this a product to a power, because well, we've got 2 times a to the 2/3 times b to the 3/5. So we're multiplying all of those and taking them to the power. That means that all of those parts have to be taken to the power. So you've got 2 to the 3rd power times a to the 2/3 to the 3rd power. And if you're taking a power to a power, you're going to multiply those powers. So times 3 over 1. And then you've got times b to the 3/5. And that also needs to be raised to the 3rd power. When you raise a power to a power, you multiply that. And in this case, the 3's will reduce. In this case, they won't. So now what we end up with is 2 to the 3rd, which is 8. 2 times 2 is 4 times 2 is 8. And then a, and these 3's canceled, so all we have is a squared now, because we had 2/3 times 3 over 1. Did you see what I did there? 2/3, 2 over 3 times 3 over 1 is what I did here, and the 3's canceled. So now I just have 2 over 1, which is the same as 2. All right, and now multiply across. Because there's nothing that will cancel, our b is going to be to the 3 times 3 is 9 on top. Whoop, 9. And 5 times 1 is 5. So b to the 9/5 power. So 8a squared b to the 9/5 power. Easy. All right, this last one puts several things together. So what we're going to do is we're going to first take the this product and raise it to the power, and then what we can do is we can bring the x cubed up and subtract it. So let's do this first part first. Do the first things first. That's a good idea. So 3 cubed times x to the 4/3 raised to the 3rd, so times 3 over 1. And then you can leave this over if you would like, over x to the 3rd for this step. So then this cancels, 3's cancel, and leaves me with x to the 4th. So now in this next step, what we'll do is, let's bring this up Oh, if I see it. Do I see? There we go. We're dividing, so we're going to subtract. Because these x's are the same base, we can just bring it up and subtract. Because it's in the bottom, it's a negative exponent because it's in the bottom. So 3 cubed, oh dear, is that 27? 3 times 3 is 9, and 9 times 3 is 27. So 27x to the 4th, and then this is to the negative 3rd power, so times x to the negative 3rd. And now when I do that, when I multiply these, I'm just adding the exponents. So 4 minus 3 is just 1x. So I've got 27x is my final answer. Another way you could see that is because the x to the 4th is on top and the x 3rd is on bottom, what you could have done, if it's easier for you to see this way, this is x times x times x, and this is x to the 4th, 1, 2, 3, 4. So we can cancel out 1, 2, 3 of them, and 1x is left on top. So either way that it's easier for you to see and understand, both of those are correct. To get you the same answer. Okay, the last section on your homework is going to be to take this root and make it into a smaller root. So what you're going to do is, can you simplify this, honey? Can you reduce it? The way you're going to do that is take that root and first change it into a fraction exponent, and then reduce the fraction, and then turn it back into a root. Okay, let me show you what I mean. So the 6th root of 49 is the same as, remember, 49 to the 1/6 power. Well, what we can do is we can say, well, 49 is 7 squared, right? So we can say, and actually, you know what? Let's do that first. Let's leave that in the, let's break this down as far as it can. So let's say 49 is 7 squared. And leave that in the 6th root. That's easier to do it that way. To look to see, okay, break that down as far as you can. Because now you've got 7 to the 2/6 power. Do you remember that? Do you remember the power is your numerator, the root is your denominator. So 7 to the 2/6 power. And now this 2/6 will reduce down to 1/3. So 7 to the 1/3 power is the same as the cube root of 7. Ha-ha! So we've reduced this down, simplified it. Okay? This one, honestly, with variables, it's easier because you don't have to, you honestly don't have to see the relationship between the numbers and the squares. All you have to do is look at the numbers and the fractions. So what we have here is, remember, x to the 4/6 power, and 4/6 will reduce. 2 will go into both. 4 divided by 2 is 2. 6 divided by 2 is 3. So now we just have x to the 2/3, which is the same as x to the 2/3 power, and you're done. All right? So that last section, this is the last section of your homework. What you're going to do is you're going to take the root, change that root to a fraction exponent, and then reduce, and then change the fraction exponent back to a root. All right? And that'll be a simplified root. All right, not too bad. I think that as long as you have these rules in your notes that you can go back to, it's the same. You've done this before. Now you just have to remember the same rules with fractions. Easy. All right, I'll see you soon.